Let's talk about L'Hopital's rule, specifically the 0 over 0 case, and talk about why it works. So when you're finding a limit, the first thing you do is you substitute a n. So that means basically when I get 0 over 0, the limit of as x approaches a of f of x and the limit as x approaches a of g of x are both 0. So I'm going to draw a picture of that. So f of x I'm going to make blue. Let's say f of x gets closer to x equals a, say there. And g of x we're going to draw in green. So it has to do something like that. Now, one of the rules for L'Hopital's rule is that f and g both have to be differentiable, which means at that point they have to be continuous. So there is an existing point there. All right. That also means, if they're differentiable, that these two graphs have tangent lines. So if I were to draw the tangent line to f of x at x equals a, and the tangent line to g of x at x equals a, what I'm going to do is write the equations of those two lines, okay? Starting with f of x. So with f of x, I'd want the slope of the tangent line, and the slope would be found by taking the derivative and plugging in a. So the slope of the tangent line is f prime of a. And then the point there is going to be a comma 0. So if I write that equation of a tangent line to f of x at x equals a, that's going to be y minus 0 equals f prime of a times x minus a. So y equals f prime of a times x minus a. If I do the same thing with g and find its tangent line, the slope at x equals a would be g prime of a, and then your point would again be a comma 0. So the tangent line to g is going to be y minus 0 equals g prime of a times x minus a. Now, keep in mind, we talked about local linearity, which means if you zoomed in really close to a graph, it looks like its tangent line. And since both of these are differentiable and both of these have tangent lines, we can actually, and we're looking at a limit where we're getting really close to a value, we can actually replace the functions that we had in the original limit with their tangent lines. Now, when you do this, this is super useful because this gives us those x minus a terms that come from both of those tangent lines that cancel out. So what I end up getting is f prime of a over g prime of a, which is the same thing because we do substitution when we start, and this is differentiable, as the limit as x approaches a of f prime of x over g prime of x. QED, it is proven.